And I'm live. That is cool. Today is 3rd of September 2025, Wednesday, and we have only two questions remaining at 1400 level, and also there was one question. Wait, yep. Well, I'm live, so that is cool. There was one other question which we were unable to do earlier. This one, schedule manager, and yes, this one uses something. The solution that I came up with was working for a smaller input size, but it was not efficient for bigger input size. It was taking a lot of space and a lot of time, so that is wrong. So we will read it up and try to do it. And yep, here these two are remaining. ACM, I guess, Association for Computer Machinery, ACM Turing Awards. So that is it. So yes, we would be able to do these two, hopefully. And then we will try to do this one. Not try to do, we will do this. We will do this. And yeah, I think there might be new concepts that we are unfamiliar with at the current moment, and we will have to read up on them. So we will do that. And then we will go back in time. There is at 1300 level, there are two questions that we haven't done. This one, move and turn, and this one, divisible pairs. And then at 1200, there are three questions, and 1100, we have done all the questions before that. So that's cool. We will catch up on all the earlier past things that we haven't done. Cool. That is going to be what we do in today's stream. And with that as the introduction, let's start solving. Tape, yep, stopwatch, and yep, things are fine. Yep, yep, things are fine. And Emacs set, attached, tag, CP, TCP, CD 1400. Here also on the next window, 1400. Start new Vim, update new Vim stuff. Right. Am I in the middle of the camera? Yes, I am. That is cool. And even though YouTube says there is some error, the stream is going fine because in my OBS I see no error. So that should be cool. And yeah, there seems to be no delay in OBS. That is cool. Vim is fine. Update, update done. Now on to the question we go. Tape. Or wait. Before I begin, I can put this thing up. Cool. Problem solving mode right now, and I will shortly interact after this thing. Cool. Let's go. You have a long stick consisting of M segments numbered from 1 to M. Each segment is 1 centimeter long. Sadly, some segments are broken and need to be repaired. M segments, 1 cent. Okay. You have an infinitely long repair tape. You want to cut some pieces from the tape and use them to cover all of the broken segments. To be precise, a piece of tape of integer length t at some position s will cover segments s s1 till s plus t minus 1. Okay, okay, makes sense. You are allowed to cover non-broken segments. It is also possible that some pieces of tape will overlap. Time is money, so you want to cut at most k continuous pieces of tape to cover all the broken segments. What is the minimum total length of these? At most k continuous pieces of tape to cover all the broken segments. To cover all the, okay, what is the minimum total length of these total length of these pieces? The first line is N, M and K, the number of broken segments, the length of the stick, M, so M is going to be greater than N. Yes, M is going to be greater than M, greater than N, and N is the number of broken segments. K is the number of tips I can make, right? The maximum number of pieces you can use, and minimum total length. The second line contains n integers b1, b2 till bn, the position in M, the position of the broken segments. These integers are given in increasing order like this. N integers. Okay, I have 4 broken segments. This, and this. So at every segment, if it is fine, then I do not do anything with it. But if it is not fine, then we do something with it. So this is what we have. Total length is 100. There are 4 broken pieces, one at length 20. Yep. Yeah, now better. So total length is 100, and we have a broken piece at, let's say this is 20, not to scale, this is 30, this is 75, and this is 80. So okay, and I can at max use 2 pieces. I think I don't need to know all of this. I only care about 20, 30, 75, and 80. And to cover this thing, I would need 10, not just 10, 11. This minus this plus 1, because I also need to cover 20 and also 30. And here I would need 6, so answer is 17, which is correct. Okay, how do we go about solving this? I need the minimum distance between things. Since they are in sorted order, I know the minimum distance. And I also know K and N. So I would like to cover as K. K is the constraint. K, I don't like K. K. Here we have K as the constraint. I can ask myself, what can I ask? Here do I want to pair these two up in a single group? That would take a tape of length 10, 11. And I would only ask myself, no, I cannot know that in advance, given n and given this thing, k. Here n by k is equal to 2. So yes, but that is not very useful. because if this were 78, then I would like to pair these all of them up and pair this singular. So this does not help a lot. I can ask dynamic in dynamic programming sense 20, 30, 75, 80. I have total number of tapes, two to spare. And when I'm just considering this given two things, I would do this. Okay, I would just use one of them up and tape this up. So answer here would be 1, tape of length 1. And when I'm here, I will see how many remaining tapes I have. And yes, I will see how many remaining tapes I have. I have 1. I can just use it, and therefore the answer here using the total number of tapes would be 1. So 1 plus 1, 2. At max minimum length would be 2. Then when I am here, I see that the total remaining number of remaining tapes is 0. But that does not help me. I need to make a pair of these two, not of this. So I know among the things that I have paired till now, two of them need to be joined. Yes, two of them need to be joined. So I find the one with the minimum distance. The one with the minimum distance between them is these two. Like I have option of joining these because I can only join two adjacent ones. So I could either join these two or I could either join these two. And here the minimum distance would be 10, 11 for the tape. So I would rather join this and use a singular tape on this one. So that is cool. That is cool, and that is the best thing at this point using two tapes. So the answer here would be 11 plus 1, 12. And then we get to here and we see that the remaining number of tapes is 0. So we need to pair some of these up. We already have this thing, and if we want to pair, either we could pair this. Now since this is the best thing possible, therefore we will consider this as a singular block. Therefore if we pair these two, then the minimum length the length that would increase is 6. But if we pair these two, then the length that would increase would be 75 minus 30 plus 1, 46. So this is bad, this is good. We pair these two up and we increase the minimum total length by 6. Minimum total length, and that would be 17, and we would return 17. That does work. Let's test this one with, let's say, 20, 30, 75, 75, and 78, and 80, and K is 2. So it would be the same thing here and here. The best answer would be 1, the best answer here would be 2. And when we get to here, so how are we going to store this? While we are going, we will only store possible differences in a set, right? Possible differences. So when we are here, we can initialize our set by going to the first point. Yes, because k is at least 1, has to be at least 1. And yes, and then whenever we get to a next point, we will see the number of k's we have left. If it is 0 right here, if it is 0, then in my set, and since it is empty right now, I would compare the distance between this and the last broken segment and consider that as a distance. That is the only possible distance. So we do this, we pair them up, and then yep, yeah, we will keep adding stuff to the set. I think this will work. I think this is correct and should work. Okay, it is it. Yeah, that is fine. So we can continue with that. Boilerplate, and no, that is the wrong thing. Okay. How is the input supposed to be? N, M, and K. N, M, and K. C, N, M, K. And in the next line, I will have a vector of broken size N. Auto reference X in broken Cn. Now that is like way too long. C into X. And now our answer begins. Okay. LL length initially is, let's say, 1. It is 1. Initially it is 1. And yes, we will int I equals 1. We will start our loop from integer I equals 1. That is the first one in the broken, less than n I plus plus. And we will also need a set of integers with possible what is points, joins, initially nothing, possible joins that we could make, right? And now also k minus minus, we will reduce the number of tapes that we have. And yes, I think we don't even need this thing that we were calculating on spot, because the answer here does not matter on the answer here. It only depends on the distance which we are storing differently, which we are storing in the set. So if k greater than 0, if k is greater than 0, then we can simply use k, and will reduce k by 1, and length plus equals 1, length will increase by 1, and that is kind of, no, that is not kind of it. We will have to include in joins dot insert this distance, this distance, yes, and we will include the length of the tape that would require to join the current broken segment with the last segment, which is going to be bi current broken segment minus bi minus 1 plus 1. Else, if we don't have a nice k, then we have to do some joining. Yep, then we need to do some join. Yeah, we need to do some joining. Okay, how do we do that? To do some joining, we need, that is crazy. To do some joining, Here I have a possible join of length 11 when I'm here. When I join these two things, if I join these two things in my join set, I would have the distance this already. So that is cool. That is very cool. That is very cool, actually. Right. If this, then I will use the current join, the smallest join that I have right now, which does not include the current element that I am at. So auto IT joins auto IT equals what is pointer doing? Auto IT equals joins dot begin. I have the first iterator in the joins, and yes, now I have to compare its value if go to IT, the smallest join possible in the in between some any number of pairs which are before there, and not just that, which are in the past. How much would the length increase if I do the current join? That is also a nice question. So if I do that particular join, my length would increase by -1. If that is smaller than, or what if it is equal? If it is equal, if two joining lengths are equal, what then makes sense? So we need a multiset here. If two joining lengths are equal, that is, if I have 1, 5, 9, here joining length is 5, here also it is 5, and then and then 13, here also it is 5. And if k equals 2, the best answer would be joining these two and joining these two, and answer would be 10. If I go with my theory, I will use one here, and then when I am here, I'll see that I could either wait, joining these two is practically the same as joining these three and using this as a singular one, because here the length would be 9 and here 1, so 9 plus 1 is 10, so that is cool. I could also do that. So if this involves increase in length, this represents increase in length. If increase in length, that would take place if I do some join between elements which I have passed before. And what would be the current join? The current increase in length would be bi minus 1, right? Because in our first question we had 20, 30, and then we saw 75. So we had this as a singular thing, this as a singular thing, and we were asking about this because we had no more tape left. If we did this join, at this point we had the length equal to 2, because one for this and one for this. If we did this join and use one tape for this, our length would increase by 1 for this particular thing, plus 1, and for the segments in between of these two, which is 9. So total increase would be 10, and increase because of this would be 9, and increase because of this would be 75 minus 30 45, and this plus 1 would be there in both the things because I am adding this one for sure. So I can just compare this. If there is some earlier thing that is making a possible join, then yeah, uh, joins dot erase iterator and length plus equals. First, I will let me just increase the length plus equals go to it minus 1, but not minus 1 because that would include when I added this. What did I add? I added plus 1. So yeah, so this is cool. No, I can add just this. That is cool. Add erase and len plus plus length plus increases, and I also have to do joins dot insert bi minus bi minus 1. Else, if that is not the case, then len will be increased by bi minus bi minus 1 plus 1, and joins dot insert nothing. Do not insert anything because we just joined the current element. So that is cool. Yeah, that would be about it. And at the end, see out length. And I hope it works. I hope this thing works. Okay, a bit off. Okay, it is always greater than by 2. See out length. Let's see. It was 2 initially. Cool. When we joined 20 and 30, then it became 13. When we had 9. So to 2, we added 9, which is correct. 9 plus 1, 10. So should have been, no, no. So this is wrong. This is wrong. Okay, minus 1, minus 1. Here we have to do minus 1 because we are joining the ones in the middle. We only have to count the ones in the middle which are not currently joined. And for this also we have to do minus 1. Yes, to make it fair. And here also, if we join these two, then the increase in length would be this. Does that make sense? Length plus equals I minus 1 I. Yes, and do not add anything to joins. Yes. Okay, with close enough. Okay, what is wrong? 2, then we did 12, which is correct, which 12 is correct. 11 and 1, which is 12. And then when we were at 80, we must have compared this thing and this distance. This distance is 5. Here we added 6. Here we added 6. Length plus equals this. Ah, makes sense. Makes sense. Cool. Should that work? I think that is correct. And what we can do right now to check our solution is either just go through the whole thing that we have written or rewrite the whole thing. And we are going to rewrite. Let's go rewrite int n, m, and k, cn, uh, cn, n, m, k, take in all the things, and then a vector called b to store broken things for auto reference x n b cn x take into x and long length initially equals 1k minus minus and a multi-set of integers called joins, and for int I equals 1, I less than n, I plus plus. Now, if k greater than 0, then just k minus minus, then plus plus, and joins dot insert bi minus bi minus 1, I minus 1, and also minus 1, because joins contains the increase in length that would be there if we used this segment, if we joined this particular segment. Now, if k is not greater than 0, which is like k is not 1, then what we will do is we have to check auto iterator equals get the joins dot the smallest segment that we can join from the past. If that thing is smaller than the increase in length that would be here, which is bi minus bi I minus 1, that would be here if I joined these two, then len plus equals go to it and len plus plus, because I also joined the bith segment to my thing, and yes, and also now joins dot erase that thing because we add because we joined the two things, the two broken segments, and now we have to do joins dot insert bi minus bi minus 1, that is the length that would be increased, that is the length that would be increased if we connect these two segments. And after this, if that is not the case, if we have to join the current segment with the last broken segment, then the increase in length would be bi minus 1, and that is pretty much it. Okay, why is first one taking, yeah, it was taking more than 1 second, which was bad. And let's see if this works. I think this will work. I think this will work. Actually, hopefully this will work. Let's see. And wrong answer on test 1. Time limit exceeded. Shit, why did time limit exceed? That is something that I did not expect, because I think this is fine. We are going through only n things because of the multiset that we are using. Huh? Time limit exceeded. That is bad. That is actually bad. Okay. So maybe, yes, what we can do is time limit exceeded. I think that is because of the set, multi-set operations. Yep, that is probably because of that. So what we can do is we can calculate how many joins we will have to make and then see how many joins we have to make and then make the joins between the small, make the joins at the smallest places possible. So, okay, shit, this is actually easy. Multiset. Yes, we will use a multiset. And what we will do is for int I equals 0, I less than n, I plus plus. Joins dot insert bi, make this 1, insert bi minus 1. And not this, but bi minus 1. Because that excludes both the broken segments and only includes the things and the extra things that would be in the middle. And we do not want any overlap. Why would we want any overlap? That is just bad practice. Yes, we have all the joins now in our multiset. We could have chosen an array and then sorted the array, and this is also fine. We don't do this. And ll length equals n initially. And yep, let's see. Int extras will be depending if k, the number of joins that we can make, if it is smaller than n. If that is the case, then we are going to make some joins, which is n minus k, and k will never be greater than n. It can be equal to n, but not greater than n. Okay, so at least k, otherwise n, otherwise 0. Int extras is n minus k. Ah, if extras is we have to make some extra joins, only then we would do all of this. We will find the length like this, and now we will keep on moving. How many extra joins do we have to make for int I equals? I think vector would be better. Vector integer joins, right? And the size is going to be n minus 1, possible number of joins that we can make. Joins I minus 1. Equals this thing, and yep, cool. We have that. We can sort joins dot begin, joins dot end from the smallest to the biggest. And now for int I equals 0, I less than extras I plus plus. I plus plus length plus equals join. But what if, okay, what is the guarantee that if I make this many joins, I will join? I think I will. I think I will. I think I will. I think I will. I think this is cool. I think this is cool. Joins I. Initially length k because that is the maximum amount of joins I can make, and n, the number of broken segments, is not going to be lower than k. So initially it is k. That is, I have made as many joins as I can, as I have to. N. K is not good. N is good because n is going to be the minimum answer, and then I add the smallest joinable segments, and this feels like a tree in some sense. Let's see. Okay, that is correct. Okay. BI, and I think this is going to work. Let's test that hypothesis. Let's see. Yep, it is running and it is accepted. Okay, that is cool. That is cool. That is cool. That is cool. I can remove this thing. That is cool. It works. Es funktioniert. That is cool. So we have done our first question for the day. It used, I would not say dynamic programming, but I think this was somewhat like a graph. Constructive algorithm. Constructive algorithm would be a nice way to describe this question. And now let me rewrite this thing. And while I'm writing this, I will go through what I am doing. So first we will have to take in the inputs n, m, and k. We take in n, we take in m, and we take in k. N is the number of broken segments that we have, m is the total number of segments that we have, and k is the number of tapes that we have. And now we will have to take in the locations of the segments which are broken. We will call them b, and the size would be n, and we will just take that integer reference x in b, c in x. We have taken that, and now after that we have to return the length, minimum possible length, that is going to be, so length initially is at least going to be equal to n, because at least every segment, at best, I will get one tape for every segment, and that is going to be the minimum length. But if k is lower than n, if k is lower than n, then I will have to join some segments, and let me first find all the segments that I could join and see the smallest ones. And at the end, whenever I'm making a join, I like this. If I have a broken segment here, and I have a broken segment here, and here, and here, and I have one segment right here, one segment right here, which does not have a tape, and I need a tape for this one, right? I need a tape for this one because we have k is smaller than n. Number of tapes is smaller than the number of segments that we have to join. So if I join these two, initially this one has a tape, individual tape on this one initially, and this one also has a tape. So when I make a join, one tape will be used to join both of them. So one of their tapes would be extra, and that tape could be applied on this one. That is the total hypothesis. And then let's say I see another thing, another broken segment that is not joined, that is like broken and does not have a tape. Then let's say I join these two segments, If I join these two, then the tape on this one would be like empty, spare, and I could put it on this one, because a single tape would be joining these three segments. And I can do this in any order for any two tapes, because whenever I do a join, I will get one extra tape which I can apply on the thing that is untaped at this moment. So we have the number of tapes is lower than the number of broken segments. What do? We first find the total number of segments, total lengths of all the segments. We can use a vector for that. Vi joins, possible joins. Length would be n minus 1 because we have n broken segments. There are going to be n minus 1 adjacent pairs. So we start iterating I equals 1. Because we will be joining the current one with the last one. That is why. And I plus plus joins I minus 1 equals bi minus bi minus 1 and a minus 1. This minus 1 because we do not want to include these broken segments bi and bi minus 1 as the length that would be increased. And after this, we will sort joins dot begin and joins dot end. After that is done, let's say int I, we will have a loop for int I equals 0, I less than n minus k, I plus plus. And why do we have n minus k? Because n is the number of segments that we have and k is the number of tapes that we have. So we have n minus k segments that are broken and do not have a tape. So we will have to do n minus k joining to get n minus k number of tapes, because whenever we do one join, we get one extra tape, like we said here. So while this, what we will do is length plus equals the current smallest thing joins I, and at the end see out length. That works and that is correct. So that is pretty cool. Should just work because that is basically the same code. Yep, that does work. This one is a bit faster than the last one, and it is also not using a lot of memory. So that is cool. And now, since we have to do our research after solving a question, our research is going to include, first we will guess what the tags are going to be in this, and then we will go to the editorial. And I guess that the tags, that one of the things in the tags is going to be constructive sorting. Sorting is going to be, obviously sorting is going to be there. We are literally doing sorting and constructive algorithm, or maybe just sorting. Constructive algorithm, I'm not very sure, but sorting is going to be there. Sorting and greedy. Yes, shit, yes, this is greedy, this is very greedy, because we are sorting and then we are taking the smallest one. Greedy, yes, makes sense. And now to the editorial. What is the reason that they give? B, tape. Okay. This is just question number B. It is division. Editorial for our first Code Forces global round. Okay. There is a division 3 contest in 4 days. That's going to be fun. Okay, for this tape, let's start with n pieces of length 1 covering only broken segments, and then decrease the number of pieces used. After reducing the number of segments by x, some x of length uncovered initial segments of unbroken pieces will be covered. It's easy to see that you should cover the shortest x segments. Just to make the at most k segments, you should cover n minus k shortest initial segments. You can find their length using sorting. Yes, that is essentially what we do. So that is fine. That is fine. That is actually pretty cool. And yes, we can consider this one done. But the trouble, what was the trouble? Why did it take me 38 minutes to do this one. 38 minutes. Now, in hindsight, it seems easy. But why did it took take me? Why did I took 38 minutes to solve this? I think the reason is that I was thinking too complicated. Yeah, my framework became over engineered. I was thinking about applying dynamic programming somehow, and yep, stuff like that. And that is why I got time limit exceeded on test number one. But if I had just thought of this simple thought, that is, when I have segments, broken segments like this, I can join them in any order I want, and whenever I join two, I will get one extra tape, which I can use to fix one other broken segment that didn't have a tape. Okay, okay, that is cool. 38 minutes. And refresh. Infinite regress. Yo, almost finished. 1400 questions. Yep. Thank you. Nice work. Thank you. I always suck at code forces because it is like 2 a.m. Shit. I guess in that sense, I am very lucky because it is at 8 in the night. That is like everyone is quiet, so that is cool. To question 12. Yes, I was unable to do that one, but we only have one remaining here. We will do that and then we will do this one. I even read the editorial for this one, but I was unable to do this. I forgot what this question is actually, but I guess now I will be able to solve it. And also there is a question at 1300, which is this one, move and turn. And this one, yeah, my approach was very complicated for this. Not complicated, but very brute force. But today I think I will be able to solve it. So that would be good. And it actually sucks that it is at it the contest happens at 2 a.m. Shit. CB31. And the last 1400 question, not the last, but second last, considering 12 is also remaining. Cool. Almost done with 1400. And yes, I also want to read about in competitive programmers handbook. I want to read about range queries. Yes, because of course, range queries. I haven't read this chapter, so that would be fun. Range queries. And I also got stuck in a question related to range queries. So this is going to be cool. Cool. Yep. But now let's do this one. It says ACM, Association for Computer Machinery, I guess. Okay. Vim and my LSP is working. And yes, you said that I should use into secretaries problem yesterday. So, shit, I do not know about segment trees. I will have to read about segment trees. I do not know about segment trees. And you said that I should use GCC, but GCC in Australian Informatics Olympiad practice website has some really good questions. Okay, I will look that up, I guess. Yes. Okay, yeah, I will look that up after I am done with, yes, all of these because I get trouble while solving just these questions. And yes, you said that I should use GCC. There is a problem because Mac uses, I'm on a Mac uses Clang as the default thing and my as the default compiler, and the LSP that I use is Clang D, which is clang based. So there are just like some incompatibilities between them, which is like you have to go out of your way to do that. Yeah. Maybe when I use Linux later, I can do that. I can use GCC then. And that is why I have to use LLDB. I cannot use GDB. Yep. For now, I will be using Clang then. And on to the next question. This is the second last at 1400. Okay, cool. Okay, do we like actually have to read the italic ones? And shit, I can do this. She was to, so I decided to go to the university and participate in EACM instead of finding a new job. He wants to become a member of Bamo Bamokh's team. In order to join, he was given some programming tasks and 1 week to solve them. Mark Mashmokh is not a very experienced programmer. Actually, he is not a programmer at all. He wasn't able to solve them. That is why he asked a sequence of L integers bi till bl, where b1 bi till bl k in ascending order till n is called good if each number divides without a remainder by the next number in the sequence, formally this thing. Okay, for all in this given n and k, find the number of good sequences of length k, as the answer can be rather big modulo it with this. N and k are not going to be larger than this. Okay, of length k. Perfectly divides the next one. Isn't this easy? N and k. I start with 1. Shit, there can be multiple. Yeah, shit. N and k. In the first one, there is 3 and 2. 1, 2, 3 possible choices. And the possible sequences are 1, 2, 1, 3, and that is it. Answer is 5. It can be equal to n. How is it 5? 1, 2, 2, 2, 3, 3. Yes. Wait, that makes sense because it can be equal to the last one. Makes sense. Okay. 1, 1, 2, 2, and 3, 3. Given I have chosen 1. This very much feels like dynamic programming, but this has to be more optimized than that, because here I have to choose a sequence of k minus 1 length where the beginning character is one of these, anything. Mm, and then, yep, I think dynamic programming with recursion. Yes, with recursion. I can have in my recursive function, I can begin with 1, 2, 3 and pass these as my first choice. Then when I call the function again, I can say if I chose 3 as the first number, then the next number I can choose starts from 6. Okay, so my recursive function has to know the number that I just chose. Yes, it has to know the number that I just chose, and it has to know k's value. It has to know k's value. So if my n equals 4, first of all, there is always a trivial case. Wait, if length is 3, if k equals 3 and n equals 3, 1, 2, 2, this is also a valid sequence. That is also a valid sequence. And a sequence like this is also valid. And then this, and 2 at the end is also valid. And then 1, 1, 1, 1, 2, 2, 2, 2, that is also a valid sequence. Okay. So I will call my recursive function with k, whatever k is, -1, and also recursion with memoization. And given, I will also tell my recursive function that the choice that I just made is 1. The choice that I just made is 1. And in my recursive function call, I will have a map of pair. Pair would be a key of integers, a pair of integers, where the first integer will tell me the index that I just chose. The index that I just chose, or the smallest index that I can choose. I think the smallest index that I can choose would be a better thing. The smallest index that I can choose, and then the length, and then the length. Yes, that makes sense. The only concern is the time complexity, but I think that would be fine. And that thing is up, that is cool. For high school students, 6 Australian informatics was last week. Oh shit, okay. Wish could prepare for IOI. You can prepare for IOI. I mean, I don't know your personal situation, but I guess you can. Okay. First of all, remove all of that. And const in n equals 1 e9 plus 7. And my recursive function will return a long integer. A long is fine. It will return a long, and hardest thing is to name the thing. Recurs, and it will take integer s as in start and int k. And let's do long res equals 0 initially, and at the end return res. Return res. And we have n and k, it is 2000. We can go n square, and I think we will go n square actually. Int n and k, c in n k. I have to use my brain. Okay. Yes, I think if I do this for int I equals 1, I less than equal to ni plus plus, long response equals 0 and plus equals recurs starting from I with k as the length, and then rest take the remainder with m. and then cout res. And now inside our recursive function, we will also need a memoization thing, map integer to integer. No, no, no. Map pair of integer. Is this bad? I think this is fine. Comparing a pair is fine. Too long is going to be the answer. Int would also suffice, but just to be safe, long. We will call this memo. And if if not k, how many ways? If k equals 0, then for our example, n equals 3, k equals 2, I will, from my main function, call for start, the first recursive call for start at 1 and k at 2, which will call a recursive call. It will also start at 1 and k would be 1 there. And I think when k equals to 1, that should be my end condition, and I can, when k equals 1, I can just return the end index, that is the length, n minus s plus 1, because if I have only one possible, yeah, that should be the thing. Because if the length of my sequence is going to be 1, I can choose any number from my starting till end, both inclusive. That is why plus 1. So if k equals 1, return n. How do I know n? I have to make n a global thing. Or maybe I can just pass n, that feels more natural. Then return n minus s plus 1. Now, if that is not the case, then look, do I already have it? If memo dot count, what? And the first one is the starting point, then the next one is the k. If that is, then return memo s comma k. Otherwise, if we do not have it, then for int I equals s, I less than n, I plus plus. Yes, I need to pass in n. That makes more sense. Recurs with I k minus 1, and also pass in n. And why just recurs? I need the answer. Add it to response remainder with m. And before returning memo. But are these things overlapping? Yes, 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 yeah, yes, okay. S k equals rest. And also if n minus s plus 1, that is the maximum length I can take. If that at becomes equal to k, then also return 1. Then yes, yes, that is also one of the conditions, because I cannot reduce my k any further. I cannot always take my k down to 1. I can sometimes, but not always. No, I can always take my k down to 1, but I am also increasing my s. So I cannot always keep increasing my s. That is one thing. or I can create a condition here to not increase my I further than till some point, but this is also fine. This is also fine. Yes. Okay, no, 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 no. I will write the condition right here. I at max, what is the maximum value that I can take? I can be at max equal to n minus k. If k is 1, k is 1, minus 1. When n equals to, let's say, 3, k equals to 1, then I can go up to that thing. Mm, When I have more experience, these I would not have to consciously calculate these things, these small little implementation details. So if I do, yes, if I do k minus 1, k minus 1 represents k. Yes, what is k minus 1? K minus 1 is, I can go up to n. K minus 1 is how much I cannot go up to n, if that makes sense. So if k equals 1, I can go up to the last n, to the value n, but not lower than that, but not higher than that. Well, I won't go there anyway because I'm not going above n. So this is cool. And I have to put the same thing here. What is the s, you ask? It is not. It is 1. Makes sense. That also makes sense. Shit, is this double counting? Am I doing double counting? Well, let's retrace. When I call this, what is my base condition? When k equals 1, that is the only time that I am returning. And wait, why am I not keeping into account the division condition? Shit, I'm not taking into account the division condition. Shit. Okay, if I start my sequence with this, if I start my sequence with this character, with this I, k, when this function is called, it knows that my sequence is starting with s. Therefore, I does not plus plus. I does I plus equals s. I plus equals s. Because I want the next one to be B. And I think this would have to change, therefore, or maybe not. If I can write a thing here, if n minus s plus 1 at any point becomes lower than k, then return 0, just to be safe. I think even without this, this should work. Okay, it is still 7, which is astonishing. Okay, what is the invariance? Invariance. S is the thing from where I start my pattern. K is the things, number of the subsequence that is remaining. And okay, this thing is actually cool. This part is cool. This part is cool. Problem is with something else. If memo.count as a base condition, is my base condition correct? K equals 1, then cannot choose everything, right? I cannot just blindly choose everything. This is my range, and in my range, this is my range, and S is a possible candidate that I can choose. Now, if I divide this whole thing by S, let's say N is 4, S is 2, this thing gives, so S is counted, divide, and then plus 1, because inclusive. Shit, I actually expected this to work, but this fired up in the exactly wrong way. Shit, why is this higher? Okay, so I just have to modify this thing. N minus S plus 1. Or maybe S equals 0. If K equals 0, then if K equal. If not K, return 0. No fucking way, right? No way. 1. We have to hopeful. It is lower here and it is higher here. But that should not be the metric on which I'm judging my code. And yes, I'm not intentionally looking at the chat. This should be a basic recursion. Okay, what are we doing? We are calling this function. Yes, that is what we are doing. And if n minus s plus 1, the range from which the total number of numbers that we can choose. If it becomes lower than k, return 0. And if I relax this thing, and same here, I think this should not work. Okay. Why am I doing that? Okay. This part is correct. This part is correct. From 1 till n. 1 till n. If at any point, then return. Okay, I can optimize this. I should not do this. I cannot go till the end while the range n minus n is the total number minus k. Again, k minus 1. And minus k minus 1, that is the maximum value of I that I can afford. And if I do the same here, n minus lower than n minus k minus 1. That is the recursive approach. Response equals 0, but my base conditions doesn't seem to be right. So this thing I don't need because I'm not going out of bounds with my loop. And given s as the starting point, I know that I have to start with s. Then I first start with s, then s plus s, which is also divisible by s, and then s plus s, 3s, which is also divisible by s, and while there are numbers remaining. Yep. And if ever the range gets smaller than this, then no. Yep. Then we don't call the function. And if k ever becomes 0, return 1. 1 or 0. Let's see. I will call this with this. Yep. First function call with s equals 1 and k equals 2 right here. Let's use clang++. The name of the program is whatever this is, LLDB out b main list main and list 30, line number 30, and put a breakpoint on b32. Now run, and it is asking for my password. That is fine. I'll just enter my password and wait, I actually have to go to washroom. I'll be right back. Good morning. Tomorrow is your hackathon. Shit, you are moving all over the place from Texas to New York and now Massachusetts. That is crazy. Yep, you enjoy traveling. I guess that is the reason that you went to New York. That could be a possible reason that you went to New York because you had your hackathon. And I think Massachusetts and New York are like very close to each other on the eastern coast. Massachusetts, US. Yep, yep. It is like right there. Hmm? Yep. Wait. Yep. Yep. We are very close. So that is my theory. And I will like get back when I get this one right. And I'm using LLDB, which is amazing. LLDB is amazing. I have a breakpoint set, and now in my file, this is my code. And currently I am at this line in my debugger. If I press N for next, I will go to the next line. N, next line. L, next line. Next line. Next line. And S to step inside. And I messed up. Shit, why did I jump to the end? Shit. Shit, shit, I messed up. I messed up. I messed up. Okay, I have to set new breakpoints. Set a breakpoint at, let's say, line number 13. Right. Run. Okay, shit. It uses C to continue. And now it is asking me for input. Input is going to be these two numbers. Let's go with that. 3 and 2. Okay. Now we have this. And what we can do, frame variable to see that at this point I is not actually initialized, so it is being represented by -1. Res equals 0, which we did. We have k, which equals 2, and we have n, which equals 3. This is amazing. And then we can do n for next. Now we are inside our recursive function, and frame variable. These are the things we have: starting point at s equals 1, k equals 2, and n equals 3, which is correct. And res equals a very big value. Why is that? Because it is not yet initialized. Is k equal to 0? Nope. We will move forward. Do we have it in the memory? Nope. Res equals 0, and now if I print res, it is 0 because it has been initialized. And now step into. Now if we do print k, we should see 1. 1, and 1 is the thing. And n is of course 3. And what is s? S should be 1. Print s. S is also 1. So n minus s plus 1, that is just 3, which is not smaller than n, which is not smaller than k. So we move forward. K is not equal to 0, so we move forward. Is it in the memory? Nope. Res equals 0. And yep. Okay, yes, this makes sense. This makes sense. This makes sense. If k equals 1, then yeah. If k equals 1, then I should return. Return how much? How much? N minus s plus 1. That is my total range. But in that total range, I cannot just choose everything. The interval should be equal to s. I have to take the ceiling. So plus s minus 1. Wait, which is just n, which is just n, which makes sense, right? Yes, it does. Shit, it makes so much sense. It makes so much sense. N by s, I think it makes sense. That is what we return. Return as an integer, lower bound. And if p equals 0, then we just return. Shit, I thought this would work. So we are still messing up somewhere. Yep, quit. Lang plus plus. Lang plus plus, what is 350.cpp? That is wrong. The name of the question is be must push with the G flag, LLDB out, set a breakpoint at main, and we can set a breakpoint at line 13, be line 13, and run. Right, next, 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 next. And it didn't ask because we messed up. Okay, quit. We didn't give any input here. It was asking for input and I just entered n, but I should have entered the values of for n and k. And somehow my phone is okay. This happens. This is like so bad. Anyways, we do not have to look at that. LLDB, okay, set a breakpoint at main and run next, 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 and now it is asking for input. This is 3 and 2. Next, step into this function. Next, 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 step into this frame variable. Yes, okay. Next, okay, we are at the end. Frame variable, because k equals 1 and start also equals 1. What are we returning? Let's see, what did we return? We will see the result reflected in the value of res. Let's see, print res, and res should be 2. It is 3. Why is res 3? K was equal to 1 and starting value was 1. So n by k was equal to 1 and n was 3. N by s, which is 1, is 3, which is correct, which is correct, which is correct. So 3 is correct, 3 is correct. Yes, yes, 3 is correct. And n, okay, we went into the loop, which is not very good, which is not very good, because it is not good. It does not feel good. We are doing double counting. I think starts. When we are saying starts, we have already chosen. Have you already chosen? I think we have. Yes, we have chosen the one. Ah, shit. See ya. Yo, cool. With some knowledge for tomorrow and solve some questions. See ya. Yep. Bye. And okay, this is messed up. This is a bit messed up. Okay, let's calm down and write the actual equation. We have a recursive function R, which is taking in S and K, the remaining length, and the total length. So what does this mean? What does S represent? What does K represent? And what does N? N is like obvious. N represents the total length, maximum number N. And this is R actually. This is like R. And S is the starting length that we can choose. And K is the remaining length. And when we call this function with S, what am I telling this function? I am telling this that you have to choose k numbers, k length of subsequence, and you have to start from S to make your choice. You have to start from S to make your choice. And if that is the case, then we do this here and we start iterating I from the start, and we say that I choose I. And now from now starting at I have k minus 1 things that I have to choose. I have k minus 1 things that I have to choose, and I actually haven't. Yes. So inside the recursive function, I am making my choice for this k minus 1 elements, k elements, and I make my choice of one element which is equal to I. Yes. And I think if I do s minus n minus s, that is the total number of choices that I could make in this. Yes, that is the total number of choices that are available to me. If I do minus k minus 1. Shit. And no, that is just how many times the loop is going to go. That has nothing to do with I. Yes, that has nothing to do with I. That has actually something to do with I. That is the total number. If s equals to n equals 4, I will get n minus s, n divided by s equals 2. N by s, 2. Yes. And if k equals 1, then this, that is 1. And if I multiply the whole thing by s into this, yes, my I can go up to this thing. That is, that is correct. That feels correct, but also over-engineered. Int r equals like as in range. Uh, and now I plus equals s. Yes, yes, I plus equals s. Yes, it just feels very good that I'm doing everything exactly as it is supposed to be. And the only problem is that it is not working. Memo sk. Yes, put it into the memory and return the result. Okay. And if at any point k equals 1, okay, I have to revise my base conditions. If I already have the result, then return, right? That cannot be wrong. If k equals 0, will I ever go k equals 0? I don't think so. So even if it is here, then no. Yes, and yes. I will return before that, before k equals 0. When k equals 1, that is my base condition. If k equals 1, return n divided by s. Given this, that is the number of my choices. And I hope it works. Okay, debugger. Yes, clang g lldb. Shit. How do I kill this thing? How do I rename window? No, no, no. I think it was this. Kill window terminal. Nope. I just have to kill this pane. How to? I think it was. Shit. How to kill a pane in Emacs. X. Yep. Kill pane. LLDB out. Set a breakpoint on main and run. Next. 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 Now it is asking for input. This 3 and 2. Next. Next. Now we will go next instead and print res. So when we chose 1 as our initial thing, then we should have gotten answer 3. We got 4. 4 is not correct. 4 is wrong. Anyway, let's see. Will we make another? We went in, which is fine. And we returned 0, which is cool. But we messed up earlier. Now we will exit the loop and output the answer. Okay, continue. Set a breakpoint at main and run. Now input 3 and 2. Step into this function. N equals k, right. Let's see what this returns. This should return 3. Yes, this should return 3. Print this. It did return 3. So that is cool. One, 2, 1, 3. And also 1, 1. When I chose 1 as my starting thing. So 1, 2, 1, 3 and 1, 1 were the things. Right. So 3. And in the next iteration, I should see 1. Rest should be equal to 4. 4. It is equal to 4. That is also cool. I think I get it. Okay. I think because I am making my one choice here. Just shit. N. Because I can make the same choice again and again. Yes. I can make the same choice again and again. Yes. 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 And yes, this space condition is also correct. N divided by S because I have to make one choice and I have this many choices. Yes. 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 Hopefully. Okay, we are messing up somewhere. Quit. Yes. Clang. LLDB. We must have out. Set a breakpoint at main. Run. Next. Next. next 3 and 2, next res should be equal to 3, res should be equal to 4. It is 5, which is correct. But now I am double counting. Yes, makes so much sense. I am double counting. Okay. Okay, it does work. Shit. Okay. It does work. Now we have a choice. We could either go through the whole code again and see if it is like logically correct and then submit, or we have another choice. We can rewrite the whole thing, and we are going to rewrite. So, and also while I'm writing, I will say what I'm doing. This shouldn't have taken this long. Like, does not make sense, right? Okay, I can keep this up. Okay, int n and m and k. Wait, I went back to the last question. What is the input in this one? This I only have two numbers, n and k. K is the length of the sequence that I have to choose, and n is the total number of sequence that there are. Then C in n and k, and then L response initially is 0, or maybe I will have to use a recursive function which returns a long. It will be called recurse, and it takes in s, the starting value, and it also takes the length k that is remaining and the total length. And we will start int or ll res equals 0 at the end. At some point we will return res, the response, and here we will have res equals how many ways there are to choose when we are starting from 1, and when we are starting from 1 and there are k choices to be made, and total number is n, and then see out res with a new line. That would be it for the main, yeah, that would be it for the main function. And here, however, we would need const int m equals 1e9 plus 7. That is the modulus const, and also a map for memorizing. And okay, this map would be the thing that slows us down. Maybe. I cannot say for sure because maximum value for n and m, n and k is not very big. So this should be fine, maybe. And if k equals 1, then we return n by s, because that is how many choices we can make. And otherwise, if memo.count, if we have already found that thing, but I don't know if are there similar choices, like subproblems. Okay, what even is this? S and a return memo s comma k. Otherwise, start from here, and we will have a loop for n I equals s, I less than equal to n, and I plus equals s. And what we will have is res plus equals, call the function again, starting from I, not s, and k minus 1 is the number of choices that are remaining. And do this, then take modulus of res with m, add it into memo s comma k. The answer is res, and then return the response. Let's see, it does work here, at least in these three cases it does work. Let's see, but is it correct in general? Let's see that. Okay, at least the first three cases are fine. And then time limit exceeded. Okay, okay, time limit exceeded. We can optimize this. Are there no sub problems that are correct? Or map? Maybe map is the thing that is messing things up. Map. What do I need to remember to store an answer? What was the test case? We can see how long it takes. These were the inputs. Wait, it's supposed to take only 1 second. Shit. Quit. Yep, not slash out for this. Okay, it is taking quite long. It is actually taking quite long. Okay, that is bad. But we do have the answer. That is good, but it is taking quite long. So what is the thing that we can change? Map. I think instead of map, we can use a vector. Instead of map, we can use a vector of vector, a matrix vector vi memo size 2000. Range is at max, not 200, but 2000. Range vi range. Okay, and if so, this is tabulation with recursion, which is kind of messed up. If memo, the first one is going to be S and the second one is going to be K. If we have that, then return that. Memo S and K equals res. That should work, right? Because for every combination of S and K, we do have an answer and we can just do this. So at least we do not have the overhead for adding and looking up in a map. It is instantaneous. Let's see. Dot slash out 1415562. Okay, we are getting a different answer. We are getting a different answer. Even though the input was same, we are getting a different answer. So there are questions about the correctness. Okay, so was the earlier answer correct or this one? We can check, we can check. My phone is actually going to die, but that is fine. Happens to the worst of us. I don't know why. Okay, it is charging. It is charging. It is charging. That is cool. For the fourth one, this was the thing, and this was the answer. We can match for the fourth one. 31208775 31208753. So we are getting the correct answer. That is instantaneous. Like light. Light is not instantaneous, it takes time. It is very slow, actually, given the size of the universe. Hmm. Oh, runtime error. Okay, okay, runtime error. Okay, what is the range? What is the range? What is the range? It can be equal to 2000. So yeah, increase range by 1. Let's clang. Shit, I should have seen that. Shit. 2000, 2000. Instantaneous. Okay, shit. Range. It was because of the range. Yes, it was because of the range. See, segmentation fault? Yeah. It was out of bounds. Yep, segmentation fault. Now it is accepted. That is cool. 59 minutes, we can say. It took, or 1 hour. 1 hour to do this one. Okay. Shit. Okay, it took 1 hour to do this one. What was the thing? Why did it take me 1 hour to do this question? It was implementation and finding the optimal substructure. Yeah, if I had taken my time to actually write down this thing, the recursive call, then I could have found out the answer. Yeah, yeah, I could have done this faster if I had done the maths. This was simple dynamic programming. And this thing, memoization. I knew that I only need the starting point and the things that need to be calculated, and they are at max 2000. So if I want to create a matrix of those things, it would have integers of it would have integers of like about 10 to the power 6 integer values, which is fine. And therefore I should have begun with using a matrix and not a map, because in a matrix lookup is constant and the constant factor is like actually constant, very small. But in a map, which I was using earlier, in a map the lookup time is log of n, like ln n, log of n. So that is not very good, that is not very constant. Okay, and what would be the tags? Of course, dynamic programming, memoization maybe not, because dynamic programming will be there for sure. Dynamic programming will be there. Yeah, dynamic programming, data structure maybe also. Yeah, that is my prediction. Guess dynamic programming. Dynamic programming. Why do we have number theory? Because of this little part, n divided by s and I plus equals s. That is the only contribution of combinatorics and number theory. Let's see the tutorial. There might be more sophisticated things than this. Yep, yep. But before moving on to 1500, I have to do this one here. And yeah, not today, not today. First, I will complete these, all of these which are remaining. There are about 3 questions here, 2 questions here, and 1 here. 3 to 1, 6. 6 questions in total. And shit, this just tells me this should have been easy. This was not even that hard. This tells me that I need to do more practice on DP and things. And there is actually a friend of mine recommended at Coders DP thing. Not this. He gave me a sheet in which there were only DP questions. Yeah, he gave me a at Coders sheet in which there were only DP questions, and yeah, I can practice there. Or there is also CSES. Yep, these questions. I've done the easiest ones, which were like easy, but now hard ones have started. Yeah. Elevator rides, what the heck? Two sets, a removal game, money sums, minimal grid path. This, like, just looking at this looks very easy, but I think it would be hard. Okay, so I need to do the memorization in a way that I know the path that I take. That is cool. And let me actually show you one thing. This question, which I got wrong, edit distance, there is edit distance in competitive programmers handbook, but I'm getting this wrong. Okay, see, I've gotten this wrong like forever, but this one here, it is only wrong on one test case. And in that test case, here we have it wrong. The correct answer is 3769 and the output that I'm giving is 3770 by 1, off by 1. I don't know. And it is correct everywhere else. It is just messing up here due to some reason. I don't know why. Anyways, let's read this. Really similar problem which had a really nice observation. Let me try to find it. Yeah. The observation is like instead of storing numbers itself, you can store the multipliers of least 2, and then for each from 1 to k, the answer increases by the number of ways insert to 1, and this is fast enough for 10 power 5 for both n and k. Okay, I do not get this. The observation is like instead of storing numbers itself, you can store the multipliers at least 2, and then for each I from 1 to k, the answer increases by the number of ways to insert to 1. Prefix sum for multiplying. Uh, Maybe this approach might be in this, the one that you are suggesting. This is the question, right? And ACM, this one. Yep. DPIJ is that is similar to what we did. Okay. Okay, yes, shit. Okay, I will not read this. I will not read this because I will like to convert this from recursion to iteration. Yep, I would like to do that, but I do not get this part. Instead of storing numbers itself. Okay, let me make the recursion tree, not the recursion tree, the tabulation representation, right? And let's say I have n 1, 2, and 3. That is I 1, 2, and 3, and I have k 1 and 2. When I have 1 and I can only choose 1, then 1. Yep. And when I have to choose 1, but I only have one choice, I think this should be in reverse. I should start from the end. Yes, I should start from the end. This should be 1. This would be 0 because I cannot choose two elements. And when I want to choose two elements and I have choice of this, but also there is the division property. I don't just have to blindly choose. There is the division property. Let's just fill this manually and then see. So answer here would be this thing plus this. And yes, this this is my starting point, then the number of ways here plus the number of ways here, and okay, and here it should again be 0 because no way to choose here and here. And when I start from, okay, how does this depend on this? I have filled this. Here should be 3 when I only have to choose one, and I start from this. Okay, I can easily fill this. Okay, I can start iterating from, okay, that is what you said. That is what you said. For each I from 1 to k. So we will iterate from k. Now, this is fast enough for 1e5 for both n and k. It is similar to prefix sum, but for multiplying, and you only consider multipliers of at least 2. And the nice observation is you need to fit ones in is just the number of ways to insert ones into sequences of sequence. Okay, okay, okay. Thank you for that. Okay, let me do my stuff here. We will be iterating k I from 1 to k. I from 1 to k. Right, right. dp. This is dp. dp. Here will be our I from 1 to k. K is 2. And here is our sequence, like range, and 3. This number represents where we start from. Yes, this number represents where we start from, I guess. If we do that, let's see. If we do that, here you have 3. We will start iterating from this point, from the end. 1, answer here. Yeah, 1, 2, 3. And 2, 0. 2, here answer is 0. And 2, here answer is 1. And the here answer is 2 actually. And the total answer is this plus this. But how does answer, I mean, there are some problems, some dynamic programming problems in which we can collapse one this table in one dimension by prefix thing. Like in coin change also, we can collapse the whole 2D table into one dimensional table, and that is good. That is good. And when we are counting the number of ways to get to a sum, unique ways in coin change, then we can collapse the table. That is cool. Okay, so if I can just write the recurrence formula for this, I can do this. So my function will take in s starting point and k, whose answer will be equal to s if I start from s and k minus 1. And the base condition is if k equals 1, then we write this thing if k greater than 1. Else if k equals 1, then n minus s. Not, no. We have to have a loop. We have to have a loop. In recursion, we are trying to convert this into a iterative method. Yes, we need to convert this into a iterative method. This is the recurrent representation, but this thing is wrong. This thing is wrong because this S has to range. There will be a internal loop. There has to be an internal loop which starts from S equal to S, I equals to S, and from S I will be incremented by I plus equals S while I less than equal to N. And what would be the time complexity? For every S, this I goes from 1 till N, and for every N, we are going through N by, wait, this is like sieve. This is like the sieve algorithm because there, no, this feels like sieve. This feels like sieve of Eratosthenes is like right here because we are iterating one outer value from 1 to N, but there is also a inner value when we call the function, but then the function is calling itself again and again and again. So that is the difference. In sieve of Eratosthenes, we have a outer for loop and a inner for loop. That is it. But the idea is feels like very similar because the inner loop starts from the current I value, which is the current value for the outer loop, and X gets updated by I, and that is what we do here. I will be updated by the starting value. Feels very similar to those things. I think if I start, okay, let's create the table again. K, K is horizontal, and we iterate from 1, 2, 3. Those are the possible values for N. For okay, K we will iterate from K1 smaller to bigger. That makes sense. What does this represent? Okay, this represents the outer limit. This represents the outer limit. So answer for this is 1. Answer for this is this thing, this value plus the value here. This value plus what would be the answer here? Isn't isn't it just this thing divided by 1, 2, and this thing divided by 1, 3, and here 0, and when I have 2, this thing divided by 1, 2, and where is 5? This should be 2 because yeah, this should be 2. No, no, division is not really correct. Not really correct because it breaks up at 1. Division breaks up at 1. Yeah. Add 2. Add 2. What does in my matrix? 1 comma 2 represent? What does it stand for? It means the number of ways when n is the outer limit. So I would have to add this plus when my sequence ends at 2. When my sequence ends at 2, 1. How far do I have to take it? I have to take it only one distance before, so this thing. So m I comma 2 minus 1 plus if my sequence ends at 2, what are the ways? If my sequence ends at 2, here I have to only go back one step. I can find total number of divisors that there are, total number of divisors, which will divide 2 perfectly in this range, which is this number divided by 1. Yes, this number divided by 1. And since my sequence ends at 2, I think first one can be initial. Okay, first one can be initialized like this. First layer can be automatically initialized. Let's go for k equals 3. 1, 2, 3. That is the value of n. 1, 2, 3. And we say that the first layer has been initialized to be 1, 2, and 3. And what is the recurrence function? The recurrence function of I j is going to be equal to f I comma j minus 1, the number of ways to get up to this thing, plus the number of ways when I'm here and I choose this one as my last thing, which is going to be equal to f I minus 1 comma j minus 1. Shit, this is not going to take. So this, okay, I guess this is the thing that you are trying to convey, because here answer for the jth layer only depends on the answer for the last layer, and therefore, and also on the current element and on the last element. So answer for this thing depends on this and on this, and I just have to add them. And this is k, this is n, no. This is k and this is n. That is k, this is n, and we can initialize all of these. This will be 1. If the left value does not exist, we can take it as 0, 0. So this will be 1. And here we would have 2 plus 1, 3. And here we would have this plus this 5, which is the correct answer for that one. Okay, and here we will have 1. Yes, and here we will have 3 plus this 9. Shit. I Okay, that is fine, but I guess this is the thing that you are referring to. This is the recurrence relation. Shit. Okay. Let me code it now. Let me. I think I got this. I think I got this. Shit. Okay, if this is actually correct, then it is going to be pretty cool. Vi iter does not matter either. And we will have a range. Const int range. Wait. Int n and k. In n and k. And we will have a vector. Rows are k and vector columns are n. And not just that, but no. A singular vector, linear 1D vector. Vector, long vector, because it can get very big. Long. Response, let's call it response, and its size is going to be n plus 1. And we will initialize this thing. Iota res dot begin and res dot end from 0. Okay, it is in numeric. And yes, I'm doing a little like workaround in my local include. I have custom this thing. Like, so whenever I see a file that is not included in my own custom implementation of bits std c++ h dot h, I have to add it. Now I can remove this. Okay, now the first layer is initialized. And wait, shit, this would still not work when we have n equals 10 power 5. So I guess what you were referring to is a bit different, because this thing will still have to go for n equals I equals for n square. And if n is 10 power 5, then it is bad. It is bad. 10 power 5 is bad. So we will have I equals 0. No, we will have row. What the fuck? Okay. What is the thing that we are iterating? We are iterating from here. We have the answer for 1. We will start iterating from 2. And internally till n. Okay. I equals 2 and I less than equal to k externally I plus plus. And I don't know why this is working. Will this actually work? Okay. We will have to see. For n j equals 1, g less than equal to n. Yes, and g plus plus. What we have is res j, yes, plus equals res g minus 1. That is very simple. That is shit. Is that actually it? And then at the end, I will return the last element. Uh, okay, expected. Okay, yeah. Okay, not very revolutionary. It is bad. Yeah, but why is it 6? Here it was not 6. So the mistake is in me. Let's see. Dot slash out. and inputs are first 3 and then 2, and we only went in once. 136. 136 is like never there. Okay, we have to go the other way around. Greater than equal to 0 and a plus plus, because we need the earlier value. No, we will never go to greater than 0, because 0 is like n is not a 0. That does not make sense. Yeah. And now if this works, okay, off by 3 error. Shit. We can write the custom table for this one. 64. Is my recurrence function correct? Before we check that, what is this? This is we are solving questions on competitive programming, and we are getting good at it, trying to get good at competitive programming. This question is specifically is based on dynamic programming, which is pretty hard, which is pretty difficult. And I'll be like right back. I have to go to the washroom. I'll be right back. Yo, me back. Me totally back. And shit, I had this thing up the whole time. Okay, my bad. But this, okay, there is something specific, something wrong here. Yes. So let's go with like actual examples. In my matrix, when I am calculating m, it's for some big number, 3, 4. What is 3? 3. Okay, what is 3? What is 3? 3 is k. 3 is k and 4 is n. 3 is k, 4 is n. And what do I need to calculate this thing? 3 is k. Okay. This represents that since my current sequence will end at 4. My current sequence will end at 4. What does that mean? My current sequence will end at 4 if I'm going to choose 4 as my last number. Then I have to choose two numbers before 4. Yes, yes. Then I have to choose two numbers before 4, for which 4 could have been their last choice, or 4 minus 1. If I'm taking this as a prefix, then this should be 2 comma 4. Yes, when I chose 4 as my last number. This this will give me the number of ways to choose when 4 is my last thing of concern. But also I have to go back, right? I have to because not just 4, I also have to add m 2 comma 2, that is for all the numbers that divide 4, right? And I could have also chosen m 1 comma 2 comma 1. Yes, this plus this plus this. Yep. So this one is kind of wrong. Yep, not kind of, it is wrong. Yep, I think that is the thing that I was missing. Okay, so we have to find the factors which we can do using something similar to sieve. Okay, let's read the editorial. Let's read the editorial. Even though we have done this in recursive way, we got this right. Using recursion, we want to get this right using iteration also. For this problem, you can find the number of tokens you can save if you initially have k tokens in constant time. Then you can calculate the answer for this problem. You can find the number of tokens you can save. You can save if you initially have k tokens. Am I reading the right thing? No, this one. Let's define dpij as number of good sequences with length I that ends in j. That ends in j. That is what we mean. We also mean in our tabular depiction of the thing. Let's denote divisors. These are going to be the divisors of that end in j, of j. Yes, divisors of j. Then yeah, dp of this thing. Yes, this is exactly equal to this. This is exactly equal to this. This is exactly equal to this. This yields n into k square root of n. So we will have to find all the factors, which is fast enough to pass the tests. This yields this, which is not fast enough. Okay, but one could use the fact that following loops, following loops run in a faster time in order to achieve this. Okay, so to apply the iterative solution, we have to make a few changes. To apply the iterative solution, we first have to find the factors of all the numbers in the given range, and the range is const int range equals to 1001, let's say. Let's say that, or we can be like more obscure and write 3 plus 1. And now factors. Vi, shit, we will have a vector, a matrix of factors. Okay, which is fine, matrix of factors, fact range function void fill fact doesn't take in anything. And what are the factors? We did this like yesterday, just yesterday we did a function like this. So what do we do? For every number, do we consider 1 as a factor? And I equals 2, we will start iterating from 2, I less than range I plus plus, and we will have fact of 1 equals dot pushback 1. 1 will always be there. 1 should be a factor of every number. And now for this, we will add 1 and this current number, and we will start moving forward. Hmm? Yes. Or do I need the factors in ascending order? If I do need the factors in ascending order, then I will have to do this. For beginning, from beginning to array, I have to perform a operation on every vector and add 1 which can be done here. Now 1 is there in every number. That is cool. In every vector. Yes. And now I can start iterating from 1 and fact I dot pushback I as a factor of I, and then for int x equals I square. No, I don't even need this. Equals I, x less than range x plus equals I, and we will have fact x dot pushback, not insert, pushback I. Okay. Okay, we have the factors. Now we can start moving forward. And what was our recurrence relation? This is our relation for answer like matrix I j. Answer was summation. I will start. This one is the smallest number, or we will start from x. This is x. eh? X starts from 1, and x goes till, like, x has to go through every factor of j. J. J is our last number, and we are choosing I minus 1. So m I minus 1 is fixed, mi minus 1, and here we are iterating through x, where x is every factor of j, and we have already calculated the answer for this. So this only depends on left, on the last row. Therefore, we do not need a matrix. That is cool. We can at least save memory. But the time is hard. Time is hard. So we can, how do they write? Summation of factors. R equals L and XR. Okay, yeah, you can write that. You can write that if you are using this representation. Cool, 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 cool. Now, fill initially. Initial fill is iota res dot begin res dot end with 0. Why 0? Because res initially points to m we will have j represented here, m1 I, where I is going from 1 to k, and this is the correct answer for that. Yes, that is correct. And yep, for int equals 2 I less than n or k, n or k, n or k, at least I plus plus, but here n or k, 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 yes, yes, K equal to K equal to K. Yes, 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 yes. Yes. Hmm. So wait, so this is wrong. This is wrong. This we are representing as here M I J, and I initially is 1, which has been initialized here, and then we are iterating I from 2 till K, and K is inclusive. And for J, since this J depends on every value from 1 till J, the earlier values, not the updated ones, therefore this is going to be this is going to go from higher to lower, like in descending order. For int j equals n, while j is greater than 0 and j minus minus. Yes. What is the answer for this current thing? It is for int x. Shit. For int x in factors of this j number. T temp, we also have to store its current value because we do not want to add it twice, because factor would be included also. So we can make a change here. Yes, you can make a change here by changing this into 2i. Yes, this should be cool, and we do not need this t, and we would have res equals res of x, not equal but plus equals. Might actually work. This might actually work, or maybe not, or maybe not. Shit, it is way lower than it is supposed to be. It is way lower than it is supposed to be. Maybe I am messing up with this fill. Yes, I am messing up with this fill fact function because I'm not calling it. Okay, I was expecting this to work this time, but anyways, it doesn't work. Symmetry, bro, how to become pupil? I just started doing 1200s. That is cool. Just keep doing questions and yeah, keep doing questions and keep reading stuff. Keep reading things that you do not know about, like graphs of dynamic programming, right? And be consistent. That is the only thing. Practice, practice and consistent. That is the only thing that you need. And maybe you will stop doing mistakes like I'm doing right now. Okay, okay. Where am I messing up? Where am I messing up? Uh, uh, yes. 17, not POV. Client dot slash out and2 and okay, that is wrong. That is like visibly wrong. The value for this thing, it should be 135 and not, wait, this thing, how is it 1. How's it 2? This represents matrix. This represents M1 eh, 3, M1 3, M1 3. Hmm? Right? M1, this is 1. This value represents M1 3, 3 when I end at 3. When I end at 3, there is only one possible answer, but I can choose the same value again and again. That is also an option. M13, 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 M13. What does 1 here means represents k and n represents this. If I end my sequence at 1, when I'm only choosing one thing, then it should remain at 1 and and not increase back, not push back, but pop back. Remove the last thing as a factor of 1. At least it is 1 now. And when we ended at it is M21, M21, M21. Shit. Maybe I'm just messing up. I have people on Code Forces solved this driver. It was I haven't done CP from last 6 months, but I wanted to qualify for ICPC. So is it possible that I do 5 hours of CP every day for 2 months that I can qualify? I think you can. I think you can if you have done, if you already know things. And yeah, I think you can. I think you can for 5 hours every day. If you are focusing, actually focusing, then you can, then you can, then you can, because you have earlier experience which will help you. And 5 hours every day is a lot of time. So yeah, you can, that is cool. It, yeah, you can. you can. You just have to believe in yourself. And apart from that, when you are actually studying, you do not have to mess around and actually work. Yep, you can. And I suppose you are better than me because what the fuck? This does not work. Let's see the evolution. Okay, we only go down once, which is fine. Okay, 1, 2, and 3 were the initial values, which is cool. 3 plus 1 is 4. 3 plus 1 is 4. 3 plus 1 is 4. Wait, it should be not 1. Okay, let me now one shot this. Should be 1 and then res 0 equals. Let me actually one shot this thing. Mm. Mhm. And then what is res? No, no. Answer is okay, okay, okay. Shh. Take modulus with m because answer can be very big. Const int m equals 1 e 9 plus 7 and this thing equals this okay, yes, this thing equals accumulate accumulate let's dot begin and let's dot end plus starting with 0. Okay, one shot. We will one shot this thing. And also shit. No. Answer plus equals answer take modulus with m. Will the accumulate function work? Okay, see, that is correct. That is correct. Shit, we one shotted this. One shot. Okay. The only concern is that when I'm summing this whole range, this thing might, no, this will not overflow because I'm using a long, long. So this will not overflow. Ideally. Wrong answer, wrong answer. So it maybe did overflow. Shit. Or maybe I gave answer that is too, we got too small. Hmm. So what is this? What is this? dot slash out 1478194 1478194. That is correct. There it wasn't correct. I was just taking a modulus. What the heck? I only took a modulus. 1478194. It is correct. Oh yeah. Okay, that is the output, but okay, that is not the correct answer. Okay, my bad, my bad. Shit. I'm giving a number that is too high. Make makes sense, I guess. Okay, we can come back to this problem. We have done this. We were just trying to do this in iterative terms. We have done this normally using recursion. We were just trying to do this in iterative terms, and we can now try to do this one. Schedule management. We got this wrong. Wrong is very different from time limit exceeded, like which is obvious. Okay, let's try to do this. If we got this right, then we would have done all the questions at 1400 level. But doing any amount of questions does not mean a lot if we do not, if we cannot redo them. This question was pretty different. I would actually like to go through this whole thing again. That would be crazy. Okay, shit. Yes. Not now, not now, not now. First, we will go as far as we can, hopefully till 1900. Okay, of course, we will go till 1900 because we have to reach 2000. We have to reach 2000. So we will go till 1900. And then, or maybe even before that, before reaching 1900, before that, we will do all of these questions which we have done and compare our performance then and now. That should be, there should be some improvement. But what is the extent of that improvement? That would be fun to see. There are n workers and m tasks. The workers are numbered from 1 to n. Each task I has a value AI, the index of worker who is proficient in that task. Shit. Feels like yesterday. Each task has a value AI, the index of the worker who is proficient in that task. In this task, every task should have a worker assigned to it. If a worker is proficient in the task, they complete it in 1 hour. Otherwise, it takes them 2 hours. The workers work in parallel, independent of each other. Each worker can only work on one task at once. Assign the workers to all tasks. N and M number of tasks is always greater than or maybe even equal to the workers, and then M for each task, which worker is efficient in that. Let's do that. But yes, that is cool. It has been already 3 hours. Okay, that is kind of strange. Feels like I just began. And yep, start new Vim, and here, not Python, CPP. And we were doing this before also, but we will write this from scratch now. Okay, we have N and M, C and N and M, take both the things. And now we are, let's say T, size will be M, and for auto X reference A, T, C and X. Yes, we have the things that we need. Now what do we do? This, this, shit, what do we even do? We will not try to simulate. That is one thing. We will not try to simulate. Simulation is bad. Okay, so a worker has some tasks. Let's say, let's store in how many tasks a given worker is proficient in, right? And that worker will do that many tasks. Yeah. And then if we store that, if we store the number of tasks that a given worker is proficient in, like in this case, there are two workers and four tasks. The first worker is good in two tasks, and the second worker is also good in two tasks. And yeah, yep. And in here we have two workers, and only one worker is efficient in the tasks. I do not actually want to simulate this thing. There should be a better method than simulation. A given worker, we have two workers, worker 1 and worker 2. Worker 1 is like efficient in four tasks, and worker 2 is not efficient. He didn't gain any skills. He didn't persevere, work hard, and okay. And in total, we have four tasks. So can we say that if worker 1 were to perform all the four tasks, it would take him 4 hours? And if worker 2 were to perform all the tasks, it would take him 8 hours. Two for every task that he is not efficient in. And if we take the average, no, why would we even take the average? The answer is going to be lower than 4. The answer is going to be minimum than any of these, yes. Well, the actual answer here would be in first hour, worker 1 would be doing one task and worker 2 would be spending 2 hours to do one task. And in those 2 hours, worker 1 would have done two tasks. And at the end of 2 hours, we would have 3 tasks completed and 1 task would remain, which would be done by worker 1 because he can do that in 1 hour. So the total answer, correct answer is 3. Correct answer is 3. But how do we get to that? I don't know, maybe my brain is just not working today. 208144 numbers. Okay, which domain does this question even goes to? I guess combinatorics. We can at least look at the the tags. Shit, we cannot. It is hidden. Shit. We can read the editorial. That is also fine. This. Okay. Struggle. Okay. Worker number 1, worker number 2. We have this one is efficient in 4 tasks. This one is efficient in 0 number of tasks. Simulation seems to be the way. In R1, worker 1 would do 1 task and worker 2 would be at the end of R1. 1 task would have been completed and worker 2 would be in the middle of 1 task. Yes. Well, the best strategy is to just give 1 task to all the workers. That is the best strategy. So there are some tasks. There are in total 4 tasks and all of them can be done efficiently by some people. Let's have the worker 1 and 2. This guy can do all the tasks efficiently and this guy cannot do any one of them. So simulation seems to be the way. I don't know. And we can read the editorial for this, which is fine, which is not bad. We do not have to feel bad because we are not having any intuitions about this thing. And this was the education round, so that is cool. And we have read this before. The statement should. Why does this happen? Okay, the last. Why do I not remember reading this line? The statement should scream binary search. Should scream binary search. Shit. Should actually scream binary search. Okay, so how do I know for a given number of time if the tasks have been completed in that given time? Even if it takes me n time to calculate that is going through all the tasks, maybe, or through all the workers, then I should be able to know. Okay, given a time t and some number of tasks, how do I know that this is done? Okay, how many okay, Okay, okay. Bool done. It takes in integer time t and vector vi tasks, which tell which worker in efficient is efficient in what task. Okay, and then we will create our vector here, tasks of size n, and for int I equals 0, I less than n, m, because there are m tasks. C and tasks c minus 1 plus plus. Increase the number of tasks there, and we will have here return, let's say, true, and we can here apply binary search. Binary search L equals 0, and R, the highest value, is going to be equal to M. It is not going to be greater than 2M. Yeah, for sure. For sure, for sure, for sure, for sure. So R is always true, done R is always true, and done L is always false. So that is our range. While R minus L is greater than 1, while I have one thing in my answer, and R is going to be my answer. So int M equals L plus R minus L divided by 2, and then I ask myself a question. If done M tasks, if done, then R equals M, right? Because that is the invariance. Else, if not done, then L equals M. And again, C out R. Now the implementation for this function. What is the implementation? Okay, for this, we will go through all the tasks, and bool d equals for int x in tasks. What is also the total number of tasks? In total number of tasks is m. Return true if m lower than equal to 0. What is m? That is a very nice question. M is nothing, and what we have is total. Let's see, in the given time, how many tasks can this current worker X do, right? He's a peasant. Can this current worker X do? Okay, we are going to get out of him everything that he can get, that he can do. So he can do, well, first of all, X tasks, total minus X. If minus equals minimum, either he completes all of his tasks or time, or time is up. Now, if there is some extra time, total minus equals extra time is t. Okay, if t greater than x, yes, total minus equals t minus x divided by 2. Yes. Huh. Wait, why is it always 1? Why is it always 1? Huh? Why is it always 1? If done, then that. Why does this done function always return true? Why does total always decrease to 0 or lower? We can use our debugger skills. We can use our debugging skills actually. But no, that is like using a bazooka. Minimum of x or t, which is correct. Tasks, yes. C minus 1 plus plus, because that is the worker who can do this task efficiently. And x the worker, x the worker. If x worker has been given t times, how many tasks can he do in the given t time? If either he does all of his efficient tasks, if he is given enough time, so either he does that or he does t number of tasks if x is greater than t. And now if t is greater than x, first of all, minimum, he did x number of tasks, then he had t minus x amount of time in which he did t minus x divided by 2 tasks. And we reduced that from the total number of tasks, which is m. So why is it always true? This shouldn't always be true. Yep. R just comes down. R just keeps on coming down because this thing is always returning true due to some reason. Y is total always lower than equal to 0. Total is a integer, total is m. Total is m. M is the total number of tasks that there are. So what gives? Let's do printf debugging. Lang for Clang plus for C schedule. Yeah, dot slash out and yep, dot slash out. I have only one test case where there are 2 workers and 4 tasks, and skills are divided like this. Okay, so total was -2 initially. then it was -2 again, and then it was 1. Why was it so? Wesley so. Why was it so? See out. No, 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 no. That is correct. That is correct. 1, 2, 4, 1, 2, 1, 2. It was 2, 2. And total number of tasks. Hmm. I'm not passing the arguments correctly. Shit. 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 Okay. Shit. This is T. Let's call this. Shit. 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 Okay. Okay. Let's call this not mid but T. Ah, shit. Okay. T. 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 Okay. What? Wait, what? Okay. Es funktioniert. It work. It does work. It does work. Hopefully, it also works here. I think it will. It should. It should. Binary search. Binary search. Shit. Okay. Binary search. We have to do some binary search questions or get some wrong answer on test number 4. Shit. We got like. Wait. Was it? Why wrong? Like literally wrong. Okay. We will not look at the test case. We will try to figure out what went wrong from here. Okay. So this thing tells me given time t and given tasks, which represents that ith worker is proficient in this many tasks, and there are in total number of tasks. Then I go through this thing and I'm here subtracting from total the total number of tasks that this current worker x is how many tasks this current worker is efficient in, and if there is enough time then he will do all the tasks, which is cool. But if he does not have enough time, then he will do t number of tasks. And then I see, does he have excess time? If he has extra time, then he will do more tasks. And to be very particular, he will do t minus x divided by 2 tasks, because it will take him, for the rest of the tasks, it will take him t minus x, that is the extra time, divided by 2 tasks, because for individual task, it will take him 2 hours. So that is correct. The implementation for this function is correct. And then this part is also correct. Abavahum. It is correct because we take in n and then we take in tasks, which is going to just represent in how many tasks is this ith worker efficient in. And this is 0 indexed. So we go through every task and we take in the number of the worker in which the ID, you could say, the index of the worker in who is efficient in this current task, and we increase his efficiency by 1, or the number of tasks that he is efficient in by 1. And then we initialize our range L equals 0 and R equals 2m, because if there are R is wrong, R is wrong, R is wrong. R should actually be 2 into m by n, right? not just this, the upper limit. So m plus n minus 1, the upper limit. And what overflow? We are not adding anything, I guess. Nope, we are not adding anything. Why is it integer? Okay, that was in, wait, is it like, why is there an integer overflow? We are not adding anything. T is something that we are returning. Okay, what are the values? What are the limitations for these things? Yep, what are the limitations? That is something that we should be aware of. That is not very big. That is not very big. That is not very big. We can make do with that. So why are we overflowing? Huh? Why do we overflow? Maybe we could underflow. And it does say overflow, but maybe we did underflow. So if t lower than 0, break. Lower than equal, not t, what the heck is t? Total. If total lower than equal to 0, then break. Or yeah, return false. If at any point, if at any point this thing happens, then return false. If we survive the ordeal, return false here. If we did all the tasks, then return true. Okay, and okay, and we have to update our range, which is cool. This is cool. This works. This should work. Hopefully, hopefully. Hope, hope, hope is what there is. Hope. Hopefully this works. Let's see. Submit. Okay, it is accepted. Okay, cool. Shit. Okay, cool. Cool. Yes, it works. It works. So we have done all the questions at 1400 rating, which is cool, which is like good. Okay. I guess, yep. So I guess now, no, let's get back to that. That was like too into the face. I guess now I will do some streams in which I read something. Tomorrow, let's do range queries. Yo, okay. Tomorrow we will do range queries. We will do range queries tomorrow. Okay, let's see how far we can get. There is also segment trees there. Okay, I do not know about segment trees. So that would be fun if we could reach till that point. That would be fun. Binary indexed tree. I do not know about trees. So tree, shortest path. So let's do trees first. Yep, let's do trees first. And let's do shortest path. Okay, we will do this. We will do this tomorrow. These three algorithms. There are three algorithms: Dijkstra, Floyd-Warshall, and Bellman-Ford. And tomorrow, let's do, yeah, let's see how many we can do. Okay, and we will also write and read the theory for these algorithms. So that is cool. Ah, the code took too long to send here. Okay, my time complexity is like, okay, Okay, yes, okay, it is cool. You got it. And if the time complexity is, if it can handle n 10 power, n equal to 10 power 9, 10 power 5, not 9, 10 power 5, it would be actually pretty cool because my implementation took, well, n square time, which is bad, n log 2k, that is good. And log n, that is good. It can handle n power 10 power 5 or even 6. Yes, it can even handle 10 power 7, right? Yeah, I guess it can even handle 10 power 7, I think. Okay, so how can you send or show me the solution? Uh, are you on Discord? Maybe you can join the Discord link in the description. There's an explanation for one of the editorials for the sparse round. Spar round editorials for the spar rounds. There is an explanation for one of the editorials for spar rounds. What is spar? Spar competitions? Competitive programming. The problem is the same. Ah, okay. SPAR, South Pacific algorithmic round. Okay. Let's see, but bounds are just higher. Okay, so you have to be smarter while you are doing those. Uh, Competitive editorial analysis. Where can I find that video? Can you send me the link? And shit, even though I've done these questions, it feels like they are not mine. Schedule management. Let me add it in the review list. I mean, at one point I will be going through all of these questions again, but anyways, tape, tape, tape is fine. It feels like I did it. And this one, this used dynamic programming, and this is the one that we are talking about. Okay. Okay, you send the link in Discord. You are in Discord. Okay. Uh, or maybe, I don't know. Okay, this is the question. Okay, cool, cool. I will see the link from there, and that is cool. And shit, it's been more than 3 hours, and I feel a bit tired. And thank you for sending the link. And yes, so it would be actually nice to see how, okay, you are unable to see the screen, you are just seeing my face. It would be nice to see actually how you can make that algorithm faster. Okay. And that would be the end of today's stream. And thank you for being here. Bye.